Day 19 notes, part 2. Students often wonder why this rule is so important. If we just rewrite as a polynomial and easily differentiate it. Answer that question simple. If it's possible to rewrite as a polynomial, always do so. But in the case of the function g of x equals x squared times sine x, there's no way to rewrite as a polynomial. So apply the product rule to find the slope of the normal line to the graph of g of x equals x squared sine x when x equals pi. So the first thing we want to do is use the product rule. So the product rule states to first take the derivative of the first term. So here's my first term. That'll be 2x. Multiply that by what we had for the second term, which is just sine x. Now we're going to leave the first term as is, but then I'm going to multiply that times the derivative of the second term. So that is the derivative. Sometimes that's all we need to do. This question asks us to go a little bit further. They want to know the slope of the normal line. Well, derivative is the slope of the tangent line. So when x equals pi, I'll be able to find the slope of the tangent line. And we know the normal line is the negative reciprocal, or the normal line has the slope that's the negative reciprocal of the tangent line because they're perpendicular. So let's first find the slope of the tangent line here and then take the opposite reciprocal of that. So every place I see an x, I'm going to substitute in pi. So what do I have here? I have 2 pi times sine of pi, that's 180. So we know the sine at 180, that's the y value is 0, plus pi squared. And then the cosine of pi, which is at 180, and the cosine is the x value, so that's going to be negative 1. So the derivative equals negative pi squared. And what do we say this represents? This represents the slope of the tangent line. And the normal line has a slope that is the negative reciprocal of our tangent line. So if our tangent line is negative 1 over negative pi squared, then the slope of our normal line is going to be 1 over pi squared, and our original slope was negative, so this is going to be positive. And that's what we're looking for. All right, that'll be it for part 2.